Hmm? Okay, today we are going to discuss 3 gate question from gate 2015. Let's start. I will request first watch the video. Then if you have any query, please let me know. Hi everyone. So first read the question and tell me the answer. The question is correct order of reactivity of para halonitrobenzene in the following reaction. So this is X is para substituted with respect to nitro and we are treating with sodium methoxide. So there is 4 options, fluorine, bromine, iodine can be X. So what will be the rate of, so which type of reaction it is? Any idea?
Nucleophilic substitutions.
Can benzene in benzene ring nucleophilic substitution is possible? If you take normal benzene ring,
Sorry, sir. This is a benzene type of mechanism.
yes, sir. So this is but in benzene ring possible because it is nitro group. So if normal benzene ring is there, then benzene has a p orbital perpendicular to the ring of this benzene ring, right? So that time nucleophile cannot attack because due to the lone pair repulsion. But if we attach any electron withdrawing group, strong electron withdrawing group like nitro, okay, then the electron density of the benzene ring decreases. That time nucleophile can attack and is normal substitution reaction is possible. Okay. And can you tell me at which position of this X is replaced? It is replaced at the same side, right? Right. So it is not the ortho position, meta position, and para position. So at because at the X where the OMe group is attacking, that's why called ipso substitution, self substitution. That's why called ipso substitution. Okay. Now any answer? I already
Option
give
C.
hints.
Option
Sorry.
C. Option C.
Okay, you are taking para hydro bromo. Why you are thinking like this? Can you tell me the reason?
Sir, Ido group is a good living group as comparison to bromo, chloro, fluoro.
Yes, yes, good, good. So, but there is some trick. Okay. So, any other answer? Okay, if not, we are. Everyone, now we're going to discuss one gate question from gate 2015, question number 29. The correct order of reactivity of para halonitrobenzenes in the following reaction is, so X can be fluorine, chlorine, bromine, iodine, and that is treated with sodium methoxide. So what will happen? There will be addition of methoxide here, and X will just came out as a living group. So we have to find out whether fluorine, chlorine, bromine, iodine, with which case the reaction will be faster. So to know this question, we have to first know what is addition elimination reaction. Normally, the nucleophile in the benzene ring addition is normally not favored because benzene have already electron-rich system because it has p orbital perpendicular to the benzene ring. That's why nucleophile when the nucleophile try to approach there will be the repulsion, electron-electron repulsion between the nucleophile electron and the p orbital of the benzene. But if the electron withdrawing group is present in the benzene ring, then this type of reaction is possible because electron with this type of electron withdrawing group takes some electron from the benzene ring. That's why the benzene ring becomes electron deficient. As a result, nucleophile can attack easily. So what happens? So nucleophile will attack here. So this type of reaction is also called ipso substitution. Ipso means cells in the same place substitution. Whether the X is attached, that center the reaction will happen. That's why this reaction is called ipso substitution, and that will form a complex here, sigma complex. Okay, and the most interesting thing is that hey, this step is the rate determining step of this reaction. So if X is electron withdrawing in nature, then nucleophilic addition, then this center will be more electrophilic, right? So if X is more electron withdrawing, then this center will be more electrophilic, then the nucleophilic attack will be highly favored. Okay, so then this complex and followed by X elimination will get the product. So as we all know that the electronegativity is like this: fluorine, then chlorine, then bromine, then iodine. Iodine, right? So in the case of when the X is fluorine, this center will be highly positive. So that time the reaction will be faster. So if the X is fluorine, then the reaction will be faster. So the rate, this is the electronegativity, and the rate will be the same order. Okay. So this is also for the rate, and this is also the order for the electronegativity. So our correct answer will be option B, fluoro, fluoro, bromo, iodo. Okay. So for more this type of information, you can watch this NPTEL video. Thank you. Is it clear to everyone?
Yes, sir.
Fine. Okay. If there is any question, let me know. Otherwise, we can play another question. So you are thinking that iodine will be the good nucleophile, so SN2 reaction will be faster, but that time SN2 reaction. For the SN2 reaction, that type of reactivity matter, but in this case, the case is reverse because the rate determining step is basically the reverse. Okay, so first you have to know in which reaction, which is the rate determining step. Hi, okay, first read the question and tell me the answer.
Option B.
Okay, option B. Any other? Okay, now let's play the video one. Now we're going to discuss one gate question from gate 2015, question number 32. Among the following, the compound that doesn't acts as a dye in the decelerated reaction is. So there is four options. So we have to find which compound will not undergo in the decelerated reaction. So what is decelerated reaction? The decelerated reaction is basically 4 plus 2 cycloaddition reaction where we this type of it undergo this type of transition state, and it will form a cyclic ring with a double bond. And here the transition state is like this: the diene and dienophile, they will come like this, so, and they will form the product. Normally the diene in the normal decelerated reaction, the diene should be electron rich, whereas the dienophile will be electron deficient in nature. So diene HOMO interact with diene LUMO. So this orbital picture, let's see, this is the HOMO, which is the Side 2 orbital, and this is the pi star orbital. So there will be the interaction like this, N-phase interaction, that only the reaction will happen. And for this reaction, this two double bonds should be in S-cis configuration. S-cis. Otherwise, the reaction will not possible. If suppose we all know that this double bond can be equilibrate like this. This is called S-cis or cissoid, or this is called S-trans or transoid. So there is a rapid equilibrium in the medium. So but if this system is locked in nature, that time this type of equilibrium is not possible. So here in this system is also locked, but they are in S-cis configuration, so the reaction will happen. But in this system, see this system is the two cyclic compound is fused together. So in this system, the rotation of this bond is not possible because it is one is 6 member, another is 5 member. So that's why it is in S-trans configuration. So that's why this compound B doesn't undergo decelerated reaction. Here, this is S-cis configuration, so it will go. Here also S-cis configuration, so this reaction will go. So this go, and this go, because these three are in S-cis configuration, whereas this B is in S-trans configuration. That's why the B will cannot act as a diene in the decelerated reaction. So the correct option will be option B. So for more information, you can watch this NPTEL video. Thank you. Any question? Okay. Is there any question?
No, sir.
Okay, fine. Hi everyone. Okay, read the question. Yeah, sorry. Any answer? Okay, it will take time. If you solving, please take time. No problem. Okay, then I am now going to discuss one gate question from gate 2015, question number 34. The mass spectrum of a dihalo compound shows peaks with relative intensity of 1 is to 2 is to 1 corresponding to M, M plus 2 and M plus 4, where M is the mass of the molecular ion respectively. The compound is, so there is a four option. In first option there is 2 bromine, next option 1 bromine, 1 bromine, in the option C 2 chlorine, and option D 1 chlorine and 1 fluorine is there. So this is the table where we summarize the isotope. For the fluorine, only one isotope is possible, 19F, and that is present in nature in 100% relative abundance. Whereas in the case of chlorine, two isotopes is present, 35 and 37, and their ratio is around, one is 100% and one is 32.5%. So we can say that 35 Cl is to 37 Cl is around 3 is to 1. and the bromine 79 bromine and 81 bromine, that is 79 bromine relative abundance 100%, and for the 81 bromine relative abundance 98%. So we can say that the bromine 79 is to bromine 81, they are present around 1 is to 1 ratio. Okay, so in this particular compound, bromine can two bromine is there. So one bromine in particular one molecule, one bromine can both the bromine can exist as a bromine 79. So the first possibility is that two bromine is there, bromine and bromine. So the M will be first case, the bromine, both the bromine can present as a 79, 79. Okay, there is another one possibility. In the case of M plus 2, let's say this is our first bromine, this is our second bromine. So in the case of first bromine, that bromine can exist as a 81, whereas this bromine can stay as a 79, or reverse is also possible, 79, 81. And in the case of M plus 4, both bromine will exist as a 81, 81. So how can we calculate the relative intensity? So for this, as the 79, 79 and the ratio is the 1. So we just will multiply to it 1 into 1. So that will be 1. In this case, 81 present also in 1, 71 also present in 1. And in this case, 79 also is present in 1 into 1. And just we have to sum these two. So it will be 2. And in the case of M plus 4, again 1 into 1, because only one possibility is there. So 1. So here the relative abundance will be M into M is to M plus 2 is to M plus 4 will be 1 is to 2 is to 1. So and here the answer will be 1 is to 2 is to 1. And in this case, what are the two atoms? Bromine and chlorine. So in the case of M, what are the possibility? Bromine can exist as a 79 and chlorine is 35. In M plus 2, bromine 79, chlorine 37 possible, and vice versa. It may be 81 and it may be 35. And in the case of M plus 4 ion, both will exist as a 81 and 37. Now we have to calculate the ratio. So bromine 79 means 1 and chlorine 35 is 3. So 3. Okay. And in the case of M plus 2, 79 and 37. So 79 abundance is 1. 37 is also 1. And in the case of 81, this is 1. But 33 is 3. So we have to add up these two. So this will be 4. And in this case, 81 is 1 and 37 is also 1. So here the ratio will be 3 is to 4 is to 1. Okay. Here the intensity ratio will be. In the case of compound C, there is two chlorine, right? So M will be chlorine and chlorine. Let's say M plus 2 and M plus 4. So both chlorine can present as a 35, 35, 35, 37 or 37, 35. Both possibility are possible. And in the M plus 4, both will be 37, 37. So in the case of 35, 35, so we have to multiply 3 into 3, 35, 37, 3 into 1, into 37, 35, 1 into 3. So this come will be 9 at 6. And in the case of 37, 37, 1 into 1, that will be 1. So here the ratio will be 9 is to 6 is to 1. And now in the case of fluorine and chlorine, M 1935, M plus 2, because here the only 19 is possible, so 19, and it may be 37, but here M plus 4 is not possible because fluorine has only one 19. Digital doesn't have time 21. That's why M plus 4 is not possible, only M plus 2 possible. So in this case, the ratio will be 1 into 3 and 1 into 1. So 3 is to 1. Here M plus 4p will be not there. So from this, the correct answer will be option A. So for more information, you can watch this NPTEL video. Thank you. Okay, is there any query or is it clear? Is it clear to everyone?
Yes, sir.
Okay. Is there any specific question whatever I discussed today? Okay, I am seeing two, three new people join today. So, Pranay, what you are doing, MSc, BSc,
Sir, MSc
from which university?
from College of Engineering and Technology, Bhubaneswar.
Okay, okay. You are in the second year, right?
Yes, sir.
What's your next plan?
Not decided yet, sir.
Okay, okay. You are appearing for GATE, right? This year?
Yeah, yes, sir.
Okay, okay. Adbhut. Okay. Is there any specific question? Otherwise, we can stop today. Any topic which is not clear. Okay, is there any query or anything else? Otherwise, you can stop today. Thank you for joining. Thank you. Thank you. Punaselli, do you have any query?